Hi, welcome back to this channel. Today in this video, I would like to talk about different types of lubricants and their properties. So these lubricants are used for various purposes in the industry and also used for things like automotives and all transportations. They all use these lubricants, the gears and various kinds of machines. So I will talk about the main types of lubricants and what are their properties that are important for their application. So before I talk about lubricants, let me introduce to you these two types of oil. So you see, one is slightly clear and less viscous, and another one is quite dark and slightly viscous. So I would like you to think about what is the difference between these two oils. They are actually same oil but under two different situations. So at the end of the video, I would like to tell you what is the difference between these two oils. So here the types of liquid lubricants. So the liquid lubricants are divided into three main types. First is the natural oils, second one is mineral oils, and then synthetic oils. Now, one thing is very important about lubricants, that two most important properties of lubricants are viscosity and boundary lubrication. So I will explain about these two terms later on, but right now we should understand about the viscosity and boundary lubrication. These two properties are extremely important for lubrication purpose. So first, natural oils. What are these materials? So natural oils are basically the oils that we obtain from nature without much processing. In this, we have the animal fats and vegetable oils. These are the two most important natural oils. So these oils or fats have been used by human beings for lubrication purpose for millennium before mineral oil started being used. So mineral oils were invented in the mid 19th century when we started getting petroleum from oil wells. Before that, throughout the history of human civilization, we have used animal fats or vegetable oils for lubrication purpose. These types of lubrication or oils are quite good for specific purposes. However, they have some problems, like they are unstable in oxidative environment. So that means they will oxidize quite easily, especially in the thermal environment. So if temperature is high, then they tend to oxidize, and because of oxidation, their property will degrade. So therefore, these oils or fats cannot be used for most of the machines because the machines tend to run at high load and high speed, which means that the temperature will increase. So the second important oils or lubricating oils are the mineral oils. The name mineral comes from mines. So that means something which we obtain from mines. So actually these oils are the oils which are derived from petroleums, and as you know, petroleum is obtained from oil wells. So these are like mines from underground. So that's why the name comes from mines to mineral oils. So that means all mineral oils are basically derived or derivatives of petroleums. The important mineral oils contain these molecules: paraffins, naphthens, aromatic or mixed aromatic and aliphatic hydrocarbons. So we can say that all mineral oils are basically hydrocarbons because the petroleum gives us hydrocarbons, various molecular weight hydrocarbons. So during the fractionation of the petroleum, we obtain materials, fuel and oils of different molecular weight, different viscosity. So the ones which have higher viscosity tends to have lubricating properties, and they are used as oils. The problem with these mineral oils is that they contain sulfur, oxygen, phosphorus, nitrogen, etc. So these are considered impurities, and they have some problems in the application. Besides, they are also contaminants for the environment. So therefore, it is important that mineral oils are purified as much as possible so that we can reduce these contents. Generally, they have lower viscosity index. Now, viscosity index is a term which we'll explain later. A high viscosity index means the lubricating oil is more stable at various temperatures. That means the viscosity does not change much with the change of temperature. So that's the meaning of viscosity index. So mineral oils tend to have lower viscosity index, which means that they are most affected by temperature. So if temperature increases, the viscosity of the oil will decrease. And as I said before, that viscosity is one of the two most important properties of an oil. So in fact, if we say one most important property of lubricating oil, that is viscosity. So if temperature changes, the viscosity will change drastically for mineral oils. The pour point is actually the temperature at which the liquid can flow out of a beaker. So pour point is in the range of -6 to -60 degrees centigrade, but generally -20 degrees centigrade. So that means at lower temperature, the material does not freeze, it can still flow. Low flash point. So flash point is the temperature at which the vapor of this material will catch fire. So lower flash point, that means this material or mineral oil is easy to catch fire. May provide sludge and varnish deposits. So these are basically the products that come out of oxidation and some other reactions. So this oil will produce sludge and varnish over a period of time as we use. So there are a lot of good things about mineral oils. They are generally very stable compared to the natural oils, and they provide excellent lubricity or viscosity and boundary lubrication. However, they have some problem, especially if we use them for very demanding application. So therefore, synthetic oils were developed. These synthetic oils, as the name suggests, these oils are produced from individual feedstock or the materials through some chemical process. So these require some chemical steps to produce these synthetic oils, although some of the chemical feeds may be derivatives of petroleum. But finally, we have to synthesize them in a chemical process. So these synthetic oils have some of the good properties which we cannot find in mineral oils. Synthetic oils also have hydrocarbons produced by polymerization, such as polyalpha olefins, organic esters, polyglycols, and silicones. Silicones are basically not hydrocarbons, so they are molecules with silicon and oxygen and various other components. Since synthetic oils are produced in a chemical process, they do not contain any impurities. The mineral oils contain impurities because these impurities come from petroleum, but for synthetic oils there is no impurity. They have very high viscosity index. That means they are very stable at different temperatures, from high temperature to low temperature. Pour point in the range of -18 to 74 degrees Celsius, but generally -30 to -50. So these pour points are even less compared to mineral oils. That means they have a good flowability even at lower temperature. And this is very important for applications like in cold countries where we have to use our machines at lower temperature. And so these oils can still provide good lubrication. Higher flash point to non-flammable. That means they can be used in applications where fire can be a big hazard. For example, aerospace. In aircraft applications, non-flammability is a very important property because in the case of fire, it is important that these lubricants do not catch fire, generally free of sludge and varnish deposits, because they have low amount of impurities and they are also very stable compared to mineral oils in terms of their chemistry. So chemically they are very stable and therefore they produce less amount of sludge and varnish deposits. These are the three main classes of lubricating oils. Now let us look at the constituents of mineral oils. Mineral oils generally contains paraffins and naphthenes, aromatic or mixed aromatic and aliphatic. So these are the main hydrocarbon molecules present in mineral oils. So based on the proportion of paraffins and naphthenes, the mineral oils have been divided into some groups. So here in this slide, I would like to present the different groups. So the lubricants are known by different groups. And what are these groups? So these groups were defined by American Petroleum Institute. Base stock categories. Base stock means the base lubricant material, because a lubricant will contain many other additives inside. So here we are only defining the base. These are the groups. Group 1, 2, 3, 4 and 5. So these are the only groups of base oils that are available in the market. So the first group is solvent refined mineral oils, which has got less than 90% of saturates. That means remaining are unsaturated. The aromatic percentage can be 10 or more than 10. There is some amount of sulfur and the viscosity index is in the range of 80 to less than 120. Group 1 lubricants are basically the lubricants which has got high amount of carbon in naphthenic molecules. So as the processing continues, with some processing or purification, the paraffinic content is increased. So that means the carbon atoms in paraffinic molecules is higher, and these are called group 2. They are purer form of the base stock of the lubricant, and they are produced by some amount of hydroprocessing. So they have saturates more than 90% and aromatic component is less than 10%. Sulfur is also controlled, is less than 0.03, and viscosity index is in the same range. But after further refining, group 3 is formed, and this is formed by hydrocracked process. So these are much purer form of base stock, same hydrocarbon oil that we obtain from petroleum, but these are much more refined and they have higher content of saturates, lower amount of aromatics, and the sulfur is also low. And these lubricants in group 3 have viscosity index of 120 or higher than 120. So we can say that group 3 lubricants are the lubricants which has got higher percentage or most of the carbon atoms are in paraffinic chains of branched chain type. So these are the purer form of hydrocarbons. Group 4 and 5 are actually synthetic oils. So group 4 are the synthetic oils which are of hydrocarbon in nature. That means their molecules are basically hydrocarbons, but they have been produced synthetically through synthetic process in a chemical plant. They have 100% saturates and aromatic components are 0 and sulfur also can be 0. The viscosity index will be much higher than 120. Group 5 are all other synthetics. That means the synthetics which are not necessarily hydrocarbons, not necessarily polyalpha olefins. There are other types of molecules which are much more complex. So these are put in group 5. So this is how we separate the base stock, the base lubricant, into 5 groups. And therefore, whenever we are going to use the lubricants, we always have to mention which group the base stock is from. And after deciding about the base stock, then we add additives into the base stock to achieve higher performance of the lubricants. Now, before ending this video, let me give you some introduction to the constituents of the mineral oils, which are the most important because in terms of volume, the mineral oils are used in the largest volume in the industry. So let me tell you some of the constituents of the base oil or base mineral oil. As we just now discussed, that paraffin is one type of molecules that are present in the base oil for mineral oils. The paraffins can be of 2 types, the straight molecule and the branch type. These are hydrocarbons, which means they have carbon as the backbone and hydrogen atoms attached to the carbon atoms. So this is a one straight chain of paraffin, and this dotted line means this molecule can be further long. So it is not ending here. More carbon atoms can be attached here. Another type of paraffin molecules are branch type. That means one carbon has got another chain which is similar to the first chain, CH3 here, and it can also be longer chains. So these are called branched paraffin. Paraffins are the most important in terms of mineral base oil because they give better properties, and that's why after refining we get molecules which are more paraffinic than naphthenic. So the naphthenes are molecules which are something like this. So it has got chain, but it also has rings of carbon atoms. These bonds are saturated bonds, so there is no double bond here. These are all single bonds between carbon and carbon, and this carbon has got bonds with hydrogen, but this is in the form of a ring. So this is called naphthenic or naphthen molecules. The third type of molecules we can see is aromatic. That means it has got benzene type of ring where this is unsaturated bonds. That means here we have got double bonds. So a good refined base mineral oil should contain branched paraffinic molecules. So the higher the paraffinic content, the better is the mineral oil. After this is the naphthen and some percentage of aromatic, up to 2 to 8% of aromatic components can be there. But as we bring the purity in the mineral base oil, we reduce the aromatic component to nearly 0, along with the other impurities. So other impurities like sulfur, phosphorus, oxygen, and nitrogen, compounds of these atoms are also reduced as we make the mineral oil more and more refined. So this is all about the lubricants, the type of lubricants that we can use in industry and automotives, and what are the main properties of the lubricants. So coming back to the issue of these two oils, this is a new fresh oil. This is a fresh synthetic oil for engines, for automotive engines, and this is the same synthetic oil but after about few months, about 5 months of running of this in the engine. So this is what happens to the oil. The lubricating oil that we add in the engine, after about 5 months it becomes like this. So now you can see that it has become very viscous, but it contains lots of degradation. So this is basically degraded oils. So there is a lot of chemical degradation as well as lot of wear particles. So the wear particle that comes out of engine as well as soot and many other impurities that get collected in the oil. So this is the engine oil after 5 months, and this is the engine oil, fresh engine oil in the beginning. In the next video, I will talk about other aspects of lubricants. For example, additives and other types of lubricants, like especially the synthetic lubricants, which are another very important class of lubricants for industrial applications. Thank you very much for joining this video.